test. Test. Alright, what's up guys? We are back today working on oleplot. Just to refresh everybody, PNG. This is how far we've gotten so far. And the main thing we need to do today is, I think, this to do. Yeah. So, if we scroll down a little bit, let's close this. We can just open it here. Basically, we're making this smaller plot area that doesn't occupy the whole image. So once we've defined the area we actually want to plot in, we need to somehow normalize the data for the plot in terms of that area. I meant to grab a piece of paper to to write out some math on, but let's just see how it goes. So the first thing I really want to do, let me go back, let's see, graph, internal image, background. So where do we call this? Graph new. So I actually want to change, what colors do we have? Okay, let's have red, green, and blue. Red, green, blue. Okay. So let's make the background blue. Okay, that's pretty slow to adapt, but there we go. Alright, so we've now made the background blue, which is kind of hard to look at, but what can you do? Okay, this is blue. This way we can just tell kind of what's going on. So we've got the background's blue. Actually, how do you make cyan? I'm assuming that it's blue and green. Blue, cyan. Perfect. Okay. So there we go. We now have the background, that color. Now the other thing I realized is that when you do this, if you take off 1/4. Well, we're actually taking 1/4 off of each side, aren't we? Yeah. So let's have that. Okay. That looks like a more reasonable plot area for sure. Okay, so there's our plot. Now, let's keep track of where we are drawing the plot rectangle. Okay. I think we're actually going to want to keep the axes on here. Graph. So our graph needs to know about its own axes. Let's do something like this. Canvas. So a canvas basically is a rectangle, but it doesn't have, it just has these beginning and end points. Okay. So now we've got a canvas. This doesn't have a canvas. How do we construct a point? Okay, so canvas is just going to be 0, 0. The default canvas just goes from 0, 0 to width, height. Okay. Okay. Now we've got our canvas, which is basically the same as the axes, but without a... It's basically the same as this rectangle, but without the color and stuff. What happened to my PNG? Alright. Fields are never used. They're about to be used. This doesn't really make sense to be here. But what can you do? For xy and self.data. Alright, it is now time to normalize the data. Let min x I guess we're just gonna do this. To do, take x and y. What is that? Take x and y. What do they call them in NewPlot? X range. X and y range. From input. Min x. Self.data. Wait, hold on. Let mute. Min x. Min y. Self.data. Dot get. Dot get dot first dot unwrap or max for xy and self.data. X less than min x equals x. What? Oh. Okay. Aloha. Hello. Okay. So we are finding the min and the max of the data. I am trying to implement a graphing program, kind of like NewPlot, if you're familiar with that. Oh, yeah, green dots, exactly. Plot. Sine x. So something like this, basically. Yes, as you can see, green dots are basically all we have so far. Yeah, plotting like Python. Yep. Yeah, green dots. Oh man. So what I'm doing right now is trying to normalize the data. So right now what I'm passing in, I think I have this just, yeah, I have it in this file. I just have some data points, 100, 100. And right now they're being plotted in like screen coordinates. So this is 100, 100, this is 150, 150, and this is 200, 200. So obviously we want the axes to run from like 0 to whatever. And then the y-axis to run vertically. My file browser. Oh, this part right here. Oh, this, if this is what you're wondering, this is projectile find file. So it just lists the files in, it lets me like fuzzy find over the files in the current projectile project. And then this is just switch to buffer in Emacs. I think there's also projectile switch to buffer, but I pretty much never use that one. Okay. Loading data. Yeah. Okay, so now that we've got the plot area defined, and we've got the min and the max, now we have to think about how to normalize the data points. And then we also then have to map that to coordinates in the plot. Okay. So the normalization is definitely going to involve the min and the max. All right, let's just start printing some stuff. That's what I usually like to do. Self.width. Okay, this is actually probably fairly close to what we want. But instead of width and height, we're going to have to use the canvas. Okay, so let's change this to this. And then self.width, let CW, this is canvas width. Yeah, printing, yes. I've actually been using GDB the past couple days. Maybe I should. I thought about streaming this actually. I've been stepping through some Fortran code using GDB. So I actually do like using a debugger. But for stuff like this, I don't mind just printing it all out. Especially, we only have like 3 data points for now. Let CW, alright, canvas width is self.canvas.beg. Well, I guess we better do .end dot 0. Alright, hold on. This is ridiculous. Yeah, I tried DAP mode too, and I just couldn't get it to work correctly. I usually use just good GDB, but I've had a really hard time getting that to work with Rust. So I'd be really interested in something that showed me how to use a debugger with Rust, because I've had a lot of trouble with it. Like if you try to print values, you try to print like a struct, and it's just crazy. You have to, I don't know. I don't know. FN width self. What are points? U32. All right, let's make a point a real data type. No, I've never programmed in Haskell. I guess I used Elm for one project, which I think is similar to Haskell. But I've always been like drawn to Haskell, but never really tried it. Oh, whoops. Circle new. Yeah, Rust is the gateway to Haskell. Yeah. Yeah, because I think in Rust I get so excited about the traits and all the type safety. It seems, yeah, like a clear progression to try Haskell. Or OCaml. I mean, I'm actually kind of drawn more towards OCaml, but I think they're both in the same family. So this should be point new. This is definitely more annoying. What is X right now? Oh. Self.canvas.width and ch self.canvas.height. Canvas new. Okay. Okay, so I think actually what we can do here is if I go back to lib point, and if I do this, sample from U32 point, yeah, why do I choose Rust over Go? I just like, basically what I was saying about Haskell is that I like the emphasis that Rust places on the type safety and also the memory safety stuff. And I like how expressive the type system is. So I was using Go for my research stuff before I switched to Rust. And this was actually before Go had generics. So I literally had to copy and paste some code that did like the same operations on different types. So that was a little lame. I also really like Rust enums and traits, stuff like that. Basically, I just like Rust. But I do actually have implementations of a lot of the same code in Go and Rust. So you definitely can do all this stuff in Go. Yes, this is what I wanted to do. Now, we can make this generic, actually. P, where P is into point. I guess the other thing is you can just say into here as well. Did I ever consider Clojure? Yes, actually. I mean, you can see I'm using Emacs. I really like Lisp, and I've always wanted to do something with Lisp, but when I've tried, yeah, basically it comes back down to the types again. And the other thing I don't like about Common Lisp specifically is the image-based development. For some reason, that really just doesn't work well for me. Like you can see here, I like to write the code. I like to have some command to just run the code and then see what happens. Yes, I do use DW and blocks. And I've never really liked having to like load a Lisp image. I do like playing with the REPL, and I think that the restart stuff you can do with Common Lisp is really cool. I mean, I've read Practical Common Lisp. I've read most of Paul Graham's on Lisp, and I use Emacs Lisp a lot. But I've just never really been able to use a Common Lisp in a real project. Yeah, and I do love the type safety. Clojure looks cool, but I haven't given it a fair shot either. Because now I'm really happy with Rust, so it's kind of, the incentive is kind of low to move away from that. So this is now a point. Is there some kind of convention for doing into inner? Why all the types have inner type? Nice. Yeah, I mean, people seem to really like Clojure. So I should give it a try at some point. Ooh, what do I dislike about Rust? Well, this is a good time to ask that question because of all the like the Rust Foundation stuff going on. I definitely dislike all of the drama that's been coming out of the Rust community. But as far as the actual language goes, probably the only thing I really don't like is that um oh the slow compilation times. That's the big thing that bothers me on a daily basis. The other thing that bothers me compared to Go is how sparse the standard library is. I guess I mean I can kind of understand taking a more minimal approach compared to Go, but what really excited me about Go is that to do all kinds of cool stuff, I didn't have to look into different like third-party libraries and see, oh, what should I be using? Like, I want to write a web server in Go. Okay, it's in the standard library. I want to use regular expressions in Go in the standard library. I want to do even like HTML templating, which relates back to the web server. It's in the standard library. Whereas in Rust, it's like I have to pick like a server library. I mean, I even have to do cargo add just to use regular expressions. So stuff like that. And I mean, I use surd or surdy, whatever, in like all of my projects. So it'd be cool if that were in the standard library as well. Yeah, and async. I haven't done async, so I haven't done much async. I would say I kind of dislike that. Like in Go, I felt pretty comfortable using Go routines and stuff, but with Rust, I've been too scared to really try much async. I've used it a little for one kind of web project I worked on, but not really, not really. So, all right, my whole idea here was to have an into inner. Just to make this easier to unpack. Okay. Yeah, that's a good point, and actually relates back to the standard library thing. Like, if you're going to use async, you have to pick an executor. It's just not, like... I really love enums and traits from Rust. Like, that stuff is really, really cool. But then it has all these weird things on the edges, like the async stuff, the standard library, the recent community drama. And those things are kind of off-putting, but it's still my favorite. I've been watching a bunch of the Primogen's videos, and he's been kind of exploring Zig lately, and I can't see myself getting into Zig. So that seems like kind of the next best option for this kind of language, and I can't see myself getting into Zig. Yeah. I know. I mean, I wanted to. Like, when the first big Rust Foundation drama came out, I was like, well, I guess it's time to check out Zig. But I just look at Zig again and can't get into it. Maybe, again, I'd have to try it and write some code. But I think I would really miss, like, the borrow checker and the guarantees that Rust gives me. So I'm not really looking for, like, a more relaxed language. So then I start thinking about, oh, should I try Haskell or OCaml? But then you're moving back towards, like, the garbage collector and stuff like that. And I don't know. Probably if I'm going to keep doing scientific programming, I should just give up and go back and learn C++ really well. Or even Fortran. Just give up on new languages completely. Okay, we've got the canvas width, we've got the canvas height. Now we need to actually normalize this. Let's try this. This is CW, and this will be CH. So, okay, that gives us... Okay, and that's still not quite right. Because that... Yeah. Yeah, I have tried reading some C++ code bases. I was trying to port what's it called, libint, because I was working on a quantum chemistry program and trying to port this, and C++ is a complete nightmare. I didn't even realize that you could that like a language server, and maybe I misunderstood this when I looked it up, but as far as I know, language servers and stuff like literally can't do stuff with C++ unless they know how the project's built. And that's basically what I found when I was deep into this code. Like, a lot of the code I don't think exists until after multiple layers of macros are expanded. It's just insane. Like, there's some, I don't even know in here, but some of this like engine stuff, engine impl, I can't even remember the exact details. But like, look at this stuff. it's just a nightmare. And I guess it's not a totally fair comparison, because this is like really intense, like really high performance code. So I can understand why they're doing this. But yeah, I mean, look at this. Yeah, but unreadable for sure. Yeah, it definitely looks insane. So sometimes you can read it and you're like, well, that looks kind of like Rust. That's not so bad. Like simple C++. But then on the other hand, you get stuff like that. And maybe I've just never seen a really complicated Rust code base, but I have a feeling it doesn't look like that. Okay, so now we don't actually... I'm doing this wrong again. Because I first need to normalize it not for the canvas. I need to see what fraction it is. Okay, so this is the canvas width and the height. Let's have data width. This is going to be max x minus min x. And what are these types? Oh, okay, F64. Fine. Let data height max y minus min y. Okay, so this is the data range. So we first divide it by this. That tells us how much of the canvas to use. X over data width, y over data height. And then we're going to multiply. Oh, these are F64s. Now we want to multiply CW as F64. Oh, very nice. When you try to code a Hartree-Fock program in Rust. How did that go? CH. I think as far as I got was just the... I did the Crawford programming project version of Hartree-Fock, but I got hung up on trying to compute the integrals myself, which gets back to this libint stuff I was just showing. So if you did any of the integral stuff, I'd be really interested to see the code. I had a hard time even finding like resources for the equations to do that, and maybe I was just nice, use MD-array. Yeah, I got a suggestion to try that on one of my projects. So I need to make one day. I'm going to stream and show the process of swapping out one for the other on that project. Oh, nice. You did the integrals. Very cool. Okay, let's see how these look. $450. Oh boy. I don't want to get myself in trouble somehow talking about the Rust community drama. I think all I really have to say, I feel like some of it is overblown a little, but I probably as much as anybody really don't like the idea of some kind of entity dictating things to us. And it feels like the Rust Foundation is trying to abuse some kind of power that I don't like. So I don't really want to be at their whim. And it would actually affect me, I think, directly in some cases. The original there, especially the trademark stuff, I think I've used the Rust logo in some of my thumbnails. So if I and everybody else interpreted the trademark stuff correctly, like I might literally have to like change my thumbnails, which just seems insane. Like I can't imagine. I would never have imagined something like that happening. I don't know. I don't really. Hopefully, that's not too hot of a take. I think. I don't know. Like, you see all the headlines, and I was getting mad, but, like, I read the thing itself, and it's like, okay. I mean, this is, like, some kind of annoying overreach by them, but. I don't know. Maybe those are, like, all the feelings I have so far. Yeah, afraid Rust is becoming a religion. I definitely get weird vibes from the Rust community. I would say that. You could probably summarize the whole thing kind of like that. All of the recent drama, including like, I'm assuming you guys have probably heard about the Rust conference talk, keynote speaker being disinvited and stuff like that. Just all the communication from the Rust people kind of weirds me out. Kind of weirds me out. I don't think Rust is a hard language to learn. At least, but that depends what languages you're coming from. So if this is your first time using types and stuff, then maybe it would be hard to learn. For me, I was coming from Go, and I felt the transition pretty easy. You really don't have to mess with lifetimes and stuff very often. Like in this project, I haven't thought about lifetimes really a single time. It takes a little practice to remember, when to use references, and you have to mark things as mutable and stuff like that. But a lot of the time, I found Rust pretty easy to write. If you start doing complicated things, like I was working through crafting interpreters, trying to port both the Java and the C code to Rust, and if you're trying to write an interpreter and you're using if you're trying to do like a linked list for like the environments or however they do it in the book, that can get very confusing. And actually, I haven't even fixed that yet. So I would say Rust is very hard to master. Like, even though I've written tens of thousands of lines, I am definitely not an expert. There are things like I can't even figure out how to get out of that lifetime mess in my interpreter. And I also have barely used any async code. So the good news is you can do a lot without being a master, but I think really learning all of Rust is very hard. Yeah, but yes, definitely. The hardest part is overcoming the stories people are telling. Yeah, dive in. It's really not hard to get started. Really, really not hard to get started. And the compiler is really helpful most of the time. You have to also remember that a lot of the stories you hear about Rust being hard are from people who tried to learn Rust several years ago. because I think compiler messages have gotten better. The compiler's inference has gotten better. Like, I think you used to have to write a lot more lifetimes yourself. Um, what else has gotten better? Probably documentation's gotten better and all that stuff. Very cool. I'm very interested gaming broadcast HD. If you have a public repo, I'd love to take a look. All right, these look pretty reasonable. Where did I learn to code? I actually have pretty much learned to code doing doing my computational chemistry research. So basically, I taught myself. Am I as good at chemistry? I I actually, to be honest, I would probably say no. I'm not as good at chemistry. um, yeah, yeah. I don't want to embarrass myself too much, but probably I would say I'm not as good at chemistry as I am at programming. And hopefully, oh man, now you guys are gonna look at my code, and if I'm bad at programming, that's like I'm really bad chemist. Um, but I'm a computational chemist, so the kind of work I do has actually involved this code. So I've worked on, well, I mean, I can show like my main research code. So this right here, push button quartic force fields. This basically produces infrared and microwave spectra of molecules. And to be honest, it's kind of like a glorified series of scripts. So all it does, I mean, all it does is it takes some initial geometry, it displaces that geometry in a bunch of different ways to map out a potential energy surface, and then it funnels those through high performance computers running all of the single point energies, gathers them up, and then does some math on them to turn them into vibrational frequencies and other spectroscopic constants. And so, I mean, I actually have a recent video that shows kind of my general research. Now, this took a couple of years to build, and there are a lot of there are a lot of fine points, especially these three programs I ported from old Fortran code. So those aren't entirely novel for me. Yeah, what levels of theory do we use? So for a lot of the really accurate stuff, where's my website? This is awesome. I'm having fun interacting with chat today. So I've got a bunch of papers, and in most of the papers we're using couple cluster theory. So I'm trying to pick, let's see, do we have any open access stuff? I know this one is open access. So in this one, I think we used, yeah, we call it F12TZ. So this is CCSD parentheses T F12B with CCP CBTZ F12 basis set. And then we also include some additional corrections. So in this case, core correlation. So we do that using, well, that's actually with this PCBTZ F12 basis set. And then we have some corrections for scalar relativity as well. Yeah, and so we look at pretty small molecules. If you're familiar with the computational chemistry side, this is a pretty expensive method. So we can only go up to about 8, 9, 10 atoms. And what comes out, what is this? Is stuff like this. So that's for one of the small, let's go up to the bigger one. You get stuff like this. So we get the frequencies in wave numbers. We get, well, we have to come up with these, the descriptions. But my code actually spits out the symmetries and stuff too. So you get all this out. It also gives us rotational constants. So basically the idea here is that we can try to reproduce experimental spectra. And in my group in particular, we usually write these things with like an astrochemical bent. So we're suggesting, um, we might be saying like, oh, astronomers should go look for this. So if you've heard of the James Webb Space Telescope, for example, that's actually doing infrared spectroscopy. So when we look at these, we look for frequencies that are within the range of JWST's instruments and also that have large intensities. So we can compute all of this stuff. And then if it's accurate enough, so we also do a lot of benchmarking to try to say it's accurate enough. But if it's accurate enough, we hope that we can support, astronomers or experimental chemists in actually detecting and identifying molecules. Yes, do we change the level of theory? Definitely. Basically, all of our work so far has been on these tiny little things. 8, 9, 10. I think maybe 9 is the highest we've gone so far. But I've also done some work on reparameterizing semi-empirical methods. So this is using MOPAC. I actually just spoke at the a MOPAC users group meeting a couple days ago. So that'll be on YouTube at some point. But basically we've been taking the default parameters in PM6 and altering those to try to tailor them to work really well on larger systems, but larger specific systems that we're interested in. I have not tried XTV yet. I've heard about it and I need to try it out. Yeah, do I think I'll keep extending QCrab? I don't know. I don't know. I would like to. Yeah, I'd like to. But we'll see. We'll see. Because I think right now, what does QCrab do right now? It doesn't do much right now. Getting back to the this libint stuff, because there are a few ways to this one. There are a few ways to go with QCrab, right? So I think so far I've implemented Hartree-Fock from the Crawford projects, right? So we've got molecules, we've got Hartree-Fock, but what I'm really interested in is actually handling basis sets properly. And I don't know. I got stuck on that before. I guess I need to look at it again. Because I would really like to get Hartree-Fock to work from the ground up without having to load integrals from disk. So I could keep moving ahead. Like I could implement MP2, I could implement CCSD using the instructions in the Crawford projects. I think, do I have a link to those here? Just in case you guys don't know, these are the Crawford Group programming projects. So Dr. Crawford is actually my academic grandfather, which is why, but I think all kinds of people use these. But our group especially uses them because my advisor was advised by Dr. Crawford. So yeah, Project 3 is Hartree-Fock. We've definitely done this. You can move ahead with MP2, CCSD. I could implement all of this on top of what I have now, CCSD parentheses T. And that would be fast. You wrote a basis set parser for GBS files. Nice. Yeah, so the problem I'm having right now, actually, okay, if you know the answer to this, I would really appreciate it. But I haven't touched this in 7 months, but I'm having trouble with d orbitals. I remember that for sure. Like with evaluating d orbitals. And I think it's because I know you can have like Cartesian and spherical representations of d orbitals, and I think that's where I'm running into issues. Yeah, try to get d orbitals working, but I'm doing it wrong. Yeah, GTO spherical. So like I'm having some trouble with d orbitals. I'm doing okay with s and p orbitals. Yeah. Yeah, so my two big problems I remember from QCram is I'm having trouble with d orbitals, which obviously restricts me from using larger basis sets beyond like STO3G. And I'm also having issues with, well, I don't think I'm actually having issues with all of the integrals. What do we have here? Refs. Yes, this is chemistry stuff. So what I'm talking about now, is basically how do you actually compute the energies of molecules, and it's pretty complicated. Yeah, 6 Cartesian, 5 spherical ones. Yeah, so I think what my problem is parsing logic. Yeah, I'm trying to do it conceptually from scratch. Oh, nice. What kind of chemistry class do you have next year? Although, so I'm trying to do it conceptually from scratch, but I was trying to rely on. I'm happy with porting someone else's code. So, for example, when I was working on the integrals, I was trying to use libint as a guide, because I mean, I think ideally you would go from the math to the code yourself, but I'm okay with going from code to code, because at least if I read it, I write it in my own language, I debug it, then at least I feel like I have a good sense for it, even if I didn't have to like come up with it myself. But as I said earlier, like libint is really really confusing, and I think basically impossible to read, if you don't compile it. Yeah, I think they're. Oh, okay. Actually, well, okay. So a Rust wrapper wouldn't really help me. If there were a Rust port of it, then I could probably read that and get a lot of information out. But if it just calls out to libint, then I'm still not going to be able to read the code. I think this is something different. Oh, wow. Look, my video comes up. Libint2. I've definitely seen this blog post before. Oh, it is the CN? Okay. But what is this? Oh, okay. Okay. So I guess cint. Is this not related to libint? Okay. Common list script. Whoa. Okay, thank you. Thank you for this. Libint, libint2, and libcint. Okay. Yeah, again, so I always defaulted to libint, or I guess libint2, because my advisor did his PhD at Virginia Tech with I guess he took classes from Ed Valeev. So I always think of, oh, libint, that's how we're gonna do it. But okay, libcint. This might actually be very helpful. Okay, I will try to read this. What's this? Oh, okay, perfect. Okay, I'll take a look at this source. If it's more readable than the than libint, which it would be almost impossible for it to be less readable than libint. I will try to put this to use. Wow. Okay, thank you very much. Yes, so there may be some QCraft streams in the future. Okay. Beautiful. All right, wait, let me see. I feel like there was some other question I wanted to talk about. What levels of theory? CCSC parentheses T. Yes, we may now be extending QCrab. That'd be awesome. Okay. And then there's also Rust libcient. Okay, this might be really interesting. Libcient. Very cool. Awesome. So this is a wrapper. Okay. Well, depending on how this goes, maybe I will make something that's not just a wrapper. Let's see, docsrs libint search. That looks like the best one. Okay, cool. Maybe I'll do a full Rust port of libcient. Very cool. Okay. Wow, that's awesome. Thank you so much. Let's see. So that's chemistry stuff. All right, let's jump back into the code. Have I tested XTB? I need to. I'm also I actually just finished my PhD, but my advisor messaged me the other day and asked about if I'd be interested in trying DFTB. So another program I'm thinking about trying. We usually use MolPro for a couple cluster or Mopac for the semi-empirical stuff. But I'm thinking about trying DFTB plus for some DFTB. Oh, I think, did I want to get back to the... Where did I learn to code? Yeah, so I learned to code basically doing this research. So I've basically never had anyone to like pair program with or had like code review. So this is basically all from reading books and my taste evolving over time. So hopefully I'm not doing anything too awful with my code. Let's get another circle. And let's try plotting these as well. For blue. Ooh. 671. Okay. $450. Okay, why is this not working? So I've got the drawing width and I've got the drawing height. Oh. Okay, let's go back to our data. Okay, let's go to a scratch buffer. So we have our max x is 200 and our max min x is 100. Okay, so the width of our drawing is 100. Okay, well, it's a straight line, so our drawing y is also 100. Okay. What is my canvas width? Canvas width is 400, or 450. Okay. Oh, I've never actually... X over dw. So dw is... Okay. Okay, hold on. I am still messing this up. So... Draw width is 100. Oh. It's not x, it's x minus min x. Y minus min y. Because we want the distance from the beginning. Let's try that. Attempted to subtract with overflow. I guess we actually want to do r dot max with cx. Oh, min. Min. Minus r. And here, r dot min cy. That way, if r is too big, we just go to 0. I guess there's also like saturating subtract. Okay, how does that look? That looks a little better, but not quite right for sure. Okay. So I'm getting 0, 0. Oh, now these need to be... Okay. So mx. So we subtract off min x over dw. And then I multiply... Okay, so let's say we want to put a point right here. Okay, our x goes from 100 to 200. And I want to plot $100. What does y go to? 100 to 200. 100 to 200. $100 to 200. So where do we put 150? So 150 is right here. Yeah, so this would be a good time for a debugger, rather than having to do this everywhere. So this, actually this is right. This is right. 0, 0 is correct. But when I actually... So this is correct. And 225, 113. These might be correct as well. 0, 0. The issue is that this is 0, 0 in canvas coordinates. Okay, so I think these are right. I think mx, my are correct in canvas coordinates, but being drawn in screen coordinates. Okay, so now we need some way to translate between screen coordinates and canvas coordinates. So 0, 0 in... Okay, now I think we need to do the same kind of thing with the canvas. Canvas width, so x minus min x, y minus min y, over the width of our drawing area. Wait, over the... Yes. Okay, let me actually debug this. is 50, and this is 100. Beautiful. 450. Okay, let's undo that. X minus min x gives me 100. 450. All right, what are the debug self.canvas? Okay, 525, 263. Uh-oh. That doesn't look quite right. 75. 225. It goes to 525, 450. All right, let's think about this a second. Okay. So, yeah, I think these are correct in canvas coordinates. So 100, 100, that's right. 0, 0 should be this one right here. Now, how do I draw that? 0, 0. Well, okay, so, I mean, 0, 0 is easy because it's just, it's not just the beginning. Okay, now it's upside down. So if I want to draw 0, 0, that is canvas. So it's actually fine in the x direction. So, okay, let mx equal mx plus self.canvas.beg.x. And let my be my. Okay, so let's see. The beginning is 37, so this is 37. This is 37 plus height, which is, yeah, whatever this is. So 263. This is the end. It's going to be minus this. So self.canvas.end.y minus my. Let's try that. There we go. Okay. We've got it. All right. Where's my debug? So now we want some margin around it. Max X. Okay, so this is a draw width. Max minus min. DW. So let's make DW 1.1 times that. So that should give us what? A little bit of margin. Okay, maybe not. So that's still 0, 0. DW over DW. Oh, because this is still like that. maybe I want... Yeah, I think we want min and max to be adjusted a little bit. Min x times equals 1.1. Max. Let's try that. No. It's only moving it on the right side. Why is that? It's because when I get 0, 0... Oh. Because I'm doing it relative to the beginning and the end. Okay. But we don't want to use the beginning. We want to use... self.canvas.bag.x. So self.canvas.bag.x equals self.canvas.bag.x plus a little is basically what's going wrong. And that little bit... Well, I don't know. Alright, forget it. We'll put them on... They're just going to go on the edges for now. Just put them on the edges. We will do... Yeah, want some margin around this. No, I think the bigger to do is just take the X and the Y margin from a file. From the input. Okay. Great. We've got data points. Take a shape for the markers. Makes sense. I mean, we can already do that, right? Okay. Anyway. Add red, blue, and cyan colors. This is all tied up with the other stuff. Shapes. Rectangle. All right. Normalize data and plot. Reasonably. Handle stroke. Take a shape. Take these ranges. Okay, good. We've handled all of the to-dos basically. Well, this is cool. CD test files. For I in X, I in range, length X. Let's print X of I, space, sign, np.sign of X of I. With open Sign dot dat right as f. F dot right. Okay, we got some data. Let's try that. Sign.dat. How does it look? Oh my goodness. It's beautiful. All right, we're plotting sine. Okay, that's pretty cool. Oh, I guess it works. I guess it works. Okay, pretty cool. Wow. It's really fun to write code that messes with images. Like getting that graphic to come out is always so satisfying. Okay. And I'm really excited too that we went from plotting these 3 points that we hard coded in screen coordinates so that they would even appear initially, to plotting this actual function, like actual data, without any issues. Okay. Wow, I'm really happy with that. Whoops. Let's get 2 sine. Where's my x? 2 pi. Oh. Beautiful. All right. There we go. Plot sine. It's beautiful. I mean, it's ugly, but the success is beautiful. Okay. So what do we need now? We need ticks. We need like x and y ticks. I mean, pretty obviously the points are too large, but that's like nitpicking. For this to be functional, we need ticks on the graph. We need labels. We need let's see, where's our readme? To do axis ticks, axis labels. Markdown, toggle, checkbox. CXX. Axis labels, title. So all of this stuff falls under font, right? Labels, title. So font stuff I'm not exactly sure how to use. Image. Can I search for font? I think we're probably going to need a composite. Okay, hold on. I saw something about this where you like put an image on top of another image. Sub image. Oh, we could have used sub image for our canvas. Image ops crop. Whoa. Whoa, this is pretty cool. Okay, that's kind of funny. Like we could probably like flip it. We could like we could like plot upside down and then flip it. Opening and saving, generating fractals. I am looking for. I know I saw this the other day. There's something you can. Well, I guess maybe it is a sub image. Sub image. Mutable view. Yeah, I guess. I think our canvas could just be a sub image, probably. Position of the top left corner. Yeah, this is probably what our canvas should be. But, let's see. Image buffers. Yeah, what I'm looking for now is some way to put an image on top of an image. Because I think there are Rust Pango bindings. And I think this is how you do... This is how we, like, draw text. I think. A library for laying out and rendering of text. So I think we can probably do something with Pango. And then you, like, put the Pango image on top of the rest of our image. Package Pango. Or Cairo? Maybe we want Cairo. File formats. Does this not actually have any documentation? I think we probably have to look at the C API. Yeah. Yeah, text is going to be a pain. That's for sure. Context. Let me go back to image real quick. All right, see you. Thanks for stopping by. Thanks for the great questions and the tips too. Thank you. Okay, let's look at this again. I really remember something about this. Dimensions. Image buffer. Image reader. Generic image. Put pixel. Blend pixel. Maybe it was in PNG. Actually, I guess you can just... Maybe it is... Maybe I am thinking of sub image. Yeah. Because if you took a sub image... Reserve the ability for all images. Ooh, Cairo RS. Okay, okay. No, this is where we were. Documentation. Okay. Create. So kind of my hope was to work with lots of different image formats, but let me try Pango. Maybe we do want Pango. Yeah, an in-memory buffer. Manual. I just want examples. Classes. Font. Ugh. This is really not helping me. Oof. Image proc. Oh. This might do it. Text. Font. Contours. Contrast. Okay. Font. Text. Draw text. What is this? Okay. Drawing. Draw text. I wonder if we're supposed to just use this. Blend. Draw text. On a new copy of an image. Oh my. I is a generic image. It does not support new lines. You must do this manually. Oof. This is going to be a mess. Alright, well anyway, let's start with axis ticks. Actually, let's make these circles a little smaller. Maybe 2. Yeah, that looks a little better. We could probably also make some of these colors better again. Gray. Make that look a little better. Okay, looks good. Okay. That looks pretty reasonable. Alright, now let's do ticks. We need to know how many ticks there are. How many ticks does he have here? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I guess we can have, like, 5 major ticks. I mean, we don't know what these are. What a terrible, terrible API. Is that even what minimax means? Yeah, that's that's not okay. We better call it min max return. Blazingly fast. Yeah, that's the best reason to use Rust. We need ticks. Axis ticks. Let's divide the canvas. Oof. Okay, so it'll be, how long do we want this to be? Axes.draw. Then we want ticks.draw. Draw ticks. 4. X in bag dot 0. Well, bag dot 0 is OX. But we don't want OX. Hold on. I think, okay, hold on. OX to in dot 0. Bag dot 0, in dot 0. Dot step by. Hold on. Can we do chunks? How do we want to do this? We want to step by 1/5, basically. It would be nice. All right. In dot 0 minus bag dot 0 over 5. Step by step dot skip 1. So we don't want to draw the first one because that's just on the axis. This should be this. Five major ticks. Let's see if these look reasonable. 165. Okay, so this self.canvas. So this is supposed to be 75, 263. So our first tick will be 165, 255, 345, 435. Okay, that looks reasonable. We only get 4 ticks. Yeah, so I think you get like one less tick than the number you put here. So if we want 5 ticks, we should do it like that. Okay, and our canvas ends at 525. So we get one over here. That looks pretty good. Now we just need to actually draw the tick. Okay, so it's 4y in end dot 1. So we want the end y minus width. We have a stroke somewhere, right? Well, we'll just do minus 2. 2 end dot 1 plus 2. Now we need to set a pixel. Self dot image dot put pixel xy black. Okay, I think it kind of worked. Plus Control X. Okay, maybe we can't zoom in. Let's make the ticks longer. Let tick len equal 4 minus tick len plus tick len. Those are ticks. Look at that. Whoops. Alright, well I can't zoom in for some reason. Okay, we got X ticks. My cursor doesn't look right, but what can you do? So these are the X ticks. And then for yn, bag.1 to n.1 dot step by step as resize dot skip 1. I think this is actually no, this is fine. 1 1 skip 1 for x in n.0 minus tick len to n.0 plus tick len let's try that. That should be our y ticks. And they're on the wrong side. Okay, because this should be bag. Oh, we also have why do we have one there? 1 2 3 4 5 6. Those are not equally spaced. I get the feeling that there's actually one being drawn there. Let's try drawing these in cyan. No. Okay, I'm messing something up. 1 2 3 4 5 6. We're getting 6 this time. And y minus bag 1. $37. Skip 1. Why is that? Why? Why does this work for this one? So we skip the first one. 74. But it goes up to 259. Goes up to 263. I mean, is this just unlucky with how we draw stuff? Skip. Can you drop one? Drop. I mean, maybe we just need to... I guess we should do it the other way, right? Because we actually want to go backwards. So now we get 225, 225, 188, 151, 114, 77, 40. All right, that's fine. That's good enough. And we don't want them to be cyan. That's pretty good. That might be good enough for today. Okay. I mean, we could also draw minor ticks if we wanted. Skip one. Draw major ticks. Tick num, tick length. In this case, we'll do self.draw ticks, bag end. Oof. So this is a lot of ticks, actually. This isn't quite going to work, is it? Because this is like 50, 2. This is going to look terrible. That doesn't look that bad, actually. That almost looks right, but not quite. To do minor ticks between major. can't just call draw ticks again because the rules. Alright, that's almost 2 hours. I think I'm ready for a break. It was fun. We got some ticks. What I wanted today was normalize the graph and then get these ticks on the board. I think fonts are going to be a real pain point, so we'll try to pick that up next time. Oh, can you do it like that? It's pretty cool. Let's just input file. This will be easy to do next time. Probably next time. Let's do. Whoops. Can you do that? Yeah. We need some kind of input format. Oh man. Yeah, I guess the minor axis stuff will be a warm up next time. And then we can play with fonts. We'll see how that goes. At least we got graphs. That looks reasonable. Pretty neat. All right. All right. Thank you to everybody who stopped by today. We had some really good discussion in the chat. I really enjoyed talking to you all. Like I was saying, next time we'll warm up with putting some minor ticks in between the major ticks that we drew today. Then we will probably try to work with Pango or Cairo or whatever works to actually draw some text on here. And if that all goes well, we will try to actually take this stuff from input rather than hard coding everything we want to try in main.rs. So, thanks everybody for stopping by. See you guys next time.